Hello, hi friends, welcome. My name is Nilesh. This video is part of the Cloud Native Ninja series, and today we are going to see how to use the Kubernetes service objects. So far in this series, we have done 10 parts and we are trying to build a polyglot programming based application which consists of a Tech Talks front end built using React, and then we have Tech Talks producer and consumer, which are decoupled using a distributed application runtime called Dapper, and they rely on a messaging platform, RabbitMQ. You can watch the previous parts of this series by going through the link which is part of the description of this video. Today's discussion is going to be focused on Kubernetes service object. Let's try to understand why do we need a service. If we look at the definition of the Kubernetes service object in the Kubernetes documentation, kubernetes.io, it says that a service is a method of exposing a network application that is running as one or more pods in the cluster. Last time we saw that when we deployed the deployment for our application, we created 3 replicas of our deployment, and all those were running as part of the same single node Kubernetes cluster. Today we are going to see different types of services which can be used and how they can be used in different scenarios. The default one is a ClusterIP. ClusterIP is used to expose the service internally within the cluster, and it is reachable only from the cluster itself. Before we go into the different types of services, we can also try and understand why do we need a service in the first place. Now, when we were looking at a single node Kubernetes cluster, all the replicas of our deployment or all the pods were running on the same node. In a typical production scenario, you would have a Kubernetes cluster built using multiple nodes. And for the purpose of this discussion, I'm going to use a managed Kubernetes cluster on Microsoft Azure cloud platform, and we will have more than one node. I'm going to use 3 node Kubernetes cluster to demonstrate that when we define or when we deploy a Kubernetes manifest file for deployment, since we use a declarative approach to just describe how the deployment has to work, we don't specify which node the deployment has to run or the pod has to run, and the Kubernetes controllers or the Kubernetes scheduler decides on which node the workload has to be scheduled. In such scenario, it is difficult for the client to know how to connect to the executing pod or executing workload. It needs a stable endpoint, and that is provided by the service object. So even if we change the replicas, if we scale the instances of our deployment, say from 3 replicas to 5, we don't have to change anything on the client side. We don't have to specify which node, which IP and which port the client has to connect to. We can create a virtual service on top of the underlying pods which are running and give a single stable endpoint to the client which can be used to connect to the service. That is the main purpose why we use a service. So as we were saying, the ClusterIP is the default one. If we don't specify the type of service, by default it will create a type of service which is accessible only within the cluster. The second type of service that can be created is of type Nodeport. This exposes the service on each and every node using a static IP. Behind the scene, it still creates the internal cluster IP, but when it is exposing to the clients outside the Kubernetes cluster, it creates a static port. And let's say we have a 3 node Kubernetes cluster and we have 2 replicas of our deployment running. These can be running on any of the nodes, and the request can be serviced by any node using this static port. The node port will take care of redirecting the traffic to the right node. The third type of service that we can create is of type LoadBalancer. LoadBalancer is used when we need the functionality to expose outside the Kubernetes cluster, and we use a cloud provider, a managed cloud service, to deploy our Kubernetes workloads. In case of my example today, I'm going to use Microsoft Azure, the Azure Kubernetes Service or AKS, which is the managed offering from Microsoft Azure. And when we create a service of type LoadBalancer, it will automatically create a load balancer by integrating with the cloud provider services. We will have a public IP using which we will be able to access our service. And the last type is the external name, where it maps the service to an external name field. It doesn't create a service within the Kubernetes cluster, but it allows the applications running inside Kubernetes cluster to access services outside the Kubernetes cluster using this external name capability. This is used sometimes when we want to connect to external database or external server and treat those services as part of internal Kubernetes cluster. So let's look at what do we need. Let's switch our attention to the code side of things. To start this example, I have already gone ahead and created the Kubernetes cluster because it takes some time to provision the cluster. And I've run two commands here beforehand. First one is to get the list of nodes. We can see that the Kubernetes cluster was created around 33 minutes ago, and it has 3 nodes, and the version of Kubernetes that it is running is 1.26.3. Similarly, I have deployed the application like we did in the previous video, and I have 3 replicas of that running. We can see that these 3 replicas were created about 17 minutes ago. If we go and describe one of this replica or one of this pod, we will be able to see on which node this is running. So when we run the kubectl describe pod command by giving the name of the pod, we can see here the node on which that particular pod is scheduled. Now in this case, it is running on node pool 1, VMSS 000. That's one way of looking at where the workload is scheduled. The other way we can look at where the workloads are scheduled is using a Kubernetes visualizer like Octant. Octant tells us where the workloads are running. So if I go into the pods section here, we can see the 3 pods for the Tech Talks or RabbitMQ producer deployment running here. And if we look at the node where they are running, each one of them is running on a separate node. And this is where we can expose this as a service. Because they are running on different nodes, we can create this service on top of this deployment and let the clients use that service from outside of the Kubernetes cluster. So I'm going to use some of the commands which you can find in the repository under this documentation 11 Kubernetes Service .markdown file. Let's first see how we can create a service. We already have the deployment, and if we use the service help command, let's see how we can use the create command with the kubectl to create a new service. If I run this command kubectl create service and the help, it will give us the top level command for creating new service and what are the different types of services. So under aliases, we can see that we can either use service or SVC, which is a short form. The available commands are ClusterIP, where it creates a ClusterIP service, or it can be external name to create an external name based service, LoadBalancer or Nodeport. This is using the imperative command, where in case of creating a deployment, same way we looked at how to create deployments using imperative command, we can create service in the same way. But I'm going to use a slightly different approach, which is by using the manifest file, and I'm going to create this using a Kubernetes manifest for the service. So let me go and apply this command or run this command kubectl create, and by giving the file producer service.yaml, we are going to create the Kubernetes service to expose our deployment outside of the cluster. Let's look at this definition in Visual Studio Code. The service has been created while we were looking at the output. So if we look at the manifest file, we can see that it follows a similar pattern like the deployment, where we specify the API version and the kind as service. Then we provide some metadata and the labels, and we use these annotations which are required for Dapper, and then we use the specification to specify how the service should be exposed or how the service should be created. In this case, we are using the type as load balancer, which means that it will use the cloud provided integration to create a public load balancer service for me. and we are specifying the ports to map the port on the service to the target port on the container. Our container is exposing 8080 port and we want the service to map to the same port. And then we use the selector, which is run, and selector is basically a key value pair which specifies how the service should interact with the underlying deployment. So in this case, we are using run and RabbitMQ producer as the selector. And if we go back to the producer deployment, I was talking about this in the previous video, where we have this match labels as the selector. In the specification for the deployment of our application, we specify match labels as RabbitMQ producer and run is the label, and that is exactly the same thing that we specify here as the selector, and that is how the service links to the backend deployment by using this selector. It is very important to have this matching, otherwise the service will not be able to redirect the traffic to the underlying deployment. And typically when there is a problem with the service, many a times it is a typo here or a mismatch which causes the service not to expose the underlying deployment. Now let's go and look at the service that was created. So I can run this commands like kubectl get service or SPC for short form, and it will list all the services which are deployed in my default namespace. And we can see that our RabbitMQ producer service with the type as load balancer and the external IP with this public IP is deployed. I'm going to copy this external IP and I'm going to request for that, or I'm going to send some load to that service. So let me use this extension in Visual Studio Code which allows me to send the request to the service, and using that public IP on 8080 port, I'm going to call this generate method to generate 100 messages or 100 tech talks. And to check that those tech talks are created, I have a RabbitMQ UI which can be used, and we can see that there was this jump in here to say there were 100 messages and some of them got picked by the consumer and they are being processed now. We can also quickly make it 1000, so we see that actually those 1000 messages are getting populated. So let's go and send another request to generate 1000 messages or 1000 tech talks, and if we go again here, we should see that jump again when the 1000 messages are populated. So that way we can see that the service is able to be called from outside the Kubernetes cluster using that public IP. That was the load balancer type of service that we were using. We can also see some of the definition or some of the features of the service here. Let's go and run some commands. So I use the create command. I can also use the apply command, where if I want to make the incremental changes to the service, if the service already exists, I can use apply. In that case, the create would fail if the service exists. So apply would apply the changes if there are any, otherwise it will not do anything. We can get the list of services that we saw. So using this command, all three, they give us the same result. The get service, get services, or get SPC. We already saw that. Let's look at what is the type of the tree that is created using the tree command. I demonstrated the tree command earlier in the series as well. This gives us the hierarchy of objects which Kubernetes creates when we create a type of higher level object, and service is one of those higher level objects here. So we want to see the tree of dependent objects which are created or related objects which are created. When I run the kubectl tree command service and give the name of the RabbitMQ producer service, we can see that there are endpoint slices type of objects created. This is basically that mapping of those three pods as the endpoints which are mapped to this service. Now let's go and see some other commands related to the services. We can also describe the service like we did describe pod earlier in this session. I can use the describe command and give the name of the service to find details about that service. So let's go and try that out. Describe is again a very high level command in kubectl or Kubernetes, which we can use to describe all types of different objects. In this case, we want the description of the service. So we can find the details like the name, namespace where the service is deployed, the different labels associated with the service, the annotations, what is the selector, the type of service, what is the IP of the or different IPs associated with this service, and various other details. So using this describe, we can see these details of the service. Well, there was one more thing I would have liked to show, but there is some problem with my laptop and it's become dead slow. I'll need to investigate why that's happening. The thing that I wanted to cover was the deletion part of the service. If I delete the service, what happens to the underlying pods which are referenced or which are exposed by means of the service? You can try this command yourself. Run the kubectl delete command, delete the service and see what happens, and let me know in the comments. With that, let's switch back to the presentation and see what did we cover during this session. This is the screenshot of the service manifest that we used, or similar to this. The important part to note here is the selector, which is used for linking the service to the underlying deployment. This has to match, and based on that, the deployment is exposed to the outside world. So what we saw as part of this video was the Kubernetes service is used to expose applications to outside the cluster. Clients, they have a stable endpoint using which they can communicate with the multiple replicas of the deployment. All the resources are available on GitHub related to this particular demo, and the slides are published to the SlideShare and speaker deck like all the previous videos. I hope you found this useful. If you find this Cloud Native Ninja series as well as the other videos on my YouTube channel, please hit the like button, subscribe to the channel and share it with your friends. Thanks for watching. Do let me know in the comments how do you find this and how I can improve. Thanks once again for watching the video. Until next time, code with passion and strive for excellence.